In this lecture, we will focus on blockchain privacy. Before introducing privacy, we will have a look at fungibility. What does it mean to be fungible? So here you can see a pound. And whether you now have this pound or whether you have this pound, they should be equal, right? If you go into a bank and you give them this pound, they will give you back the same amount of the same pound. So they're really being treated as equal as possible. Now, and this is no matter the history of this coin. You don't know where this coin went to, right? You don't know its previous owner. You don't know how many owners it has. You don't know whether it's involved in anything illegal or etc. So you basically have no history of this particular coin. Now, can we say the same about a Bitcoin? Is one Bitcoin always worth one Bitcoin? Well, not necessarily, right? If let's say you're a miner and you're mining a new block. Let's say this is your block with the transactions here. This will, for example, grant you a certain amount of coins. Depending on the block reward, let's say this is for 12.5 Bitcoins. Now, these 12.5 Bitcoins, they have no history. They're fresh. They have not been owned by anyone before, and they are technically worth more. People are more willing to accept them than so-called dirty or older coins. Now, if those older coins stem, for example, from Satoshi, maybe they would be worth a lot, right? Because there's a lot of fundamental, like sentimental value associated to them. So, and this is why we don't have fungibility in cryptocurrencies, because we can see the whole history of the transactions. Now, some blockchains obscure the history of transactions of coins, so they might achieve fungibility again. So blockchain privacy is really a multi-layer challenge, right? Again, we have like the hardware layer, we have the network layer, the blockchain or consensus layer, and then the application layer. And privacy plays a fundamental role in all of these layers, right? So for example, it matters what peers are exchanging on the network layer. It matters whether you have like a core CPU or some other process that can see what kind of transactions you're signing here. It matters if you can trace the flow of transactions. And it matters to the application layer how you define privacy, how users can be traced within this application. So privacy really is a multi-layer challenge. It's a very exciting challenge. So in this course, we focus for the time being on these following privacy solutions or proposals. They are broadly defined in two classes, and this is not everything that's out there, but this is what we discuss in the first step. So there's a native privacy solution. So native meaning the blockchain supports by default a privacy solution. So this can be either, for example, done through techniques such as ZK snarks, ring signatures, or stealth addresses. And two famous examples are Zcash, Monero, but there are others as well, like Dash or other blockchains. And then the second category are add-on mixers. So add-on mixers are protocols that you can deploy on top of an existing blockchain in order to increase the privacy of the users there, in order to go from pseudonymity to rather anonymity. And there have been many different proposals, and there exist many more other proposals that we don't have the time to go into, but just to give you a few names if you're curious to look them up.